There are moments in planetary history when a collapse does not arrive with explosions or storms, but with silence. When a world built on ancient rhythms loses its pulse. Analysts studying ocean ecosystems suggest that humanity may be living through such a moment right now. The oceans, which generate half the oxygen we breathe and regulate the temperature of the planet, are losing their biological heartbeat. Coral reefs, the structures that anchor a quarter of all marine life, are bleaching and dying in real time. And here's what nobody tells you. Coral reefs don't die slowly. They die suddenly. They die visibly. They die as if a switch has been thrown, leaving behind ghostly skeletons where vibrant ecosystems once thrived. Here's why this matters. Nearly 1 billion people depend, directly or indirectly, on coral reefs for food, tourism, storm protection, and livelihoods. Reefs are not underwater decorations. They are infrastructure. They are economic engines. They are defense systems. And right now, according to some marine biologists, they may be entering one of the most rapid collapses in the history of the oceans, if this pattern applies. This crisis did not begin today. It did not begin a decade ago. It began deep in geological time, and the blueprint was written long before humans appeared. Let me show you exactly how. The first historical parallel takes us back 252 million years to the Permian extinction, the greatest biological collapse Earth has ever recorded. During this period, volcanic eruptions triggered massive carbon releases, warming the oceans, reducing oxygen levels, and acidifying seawater. Coral reefs, unable to adapt to rapidly shifting chemistry, disappeared entirely. Some paleobiologists argue that reefs remained absent for millions of years afterward, leaving oceans barren compared to their former complexity. Not change. Erasure. The second major reef collapse occurred much more recently, in the 1980s in the Caribbean. A mysterious disease swept through the region, killing up to 98% of the long-spined sea urchins that kept algae in check. Without them, algae smothered coral structures. Reefs that once flourished began to vanish. Fisheries collapsed. Tourism suffered. Local economies weakened. At first, it looked like a temporary shock. Then, the bill arrived. By the time scientists understood the mechanism, the reefs had already passed a threshold. The ecosystem didn't bounce back. It reorganized into something simpler, poorer, less resilient. This is where the pattern begins to repeat. Once corals die, the environment that supported them changes, making recovery far more difficult than decline. The third major event came in 1998, when a massive global bleaching episode struck reefs from the Indian Ocean to the Great Barrier Reef. Temperatures rose just 1 or 2 degrees above average, yet it was enough to cause corals worldwide to expel the symbiotic algae that give them color and life. Analysts estimate that 16% of all coral reefs on Earth died that year. Not weakened, not damaged, dead. Here's what nobody tells you. Bleaching is not a passive event. It is a biological scream. It is a last attempt by a coral to survive water that has become too hot for the algae it depends on. If temperatures fall quickly enough, the algae return. If they don't, the coral starves. This brings us to the modern moment, the real-time collapse unfolding before our eyes. In 2023 and 2024, marine heatwaves surged across the Pacific, Atlantic, and Indian Oceans. Water temperatures in some regions exceeded previous records by enormous margins. Analysts suggest that the Great Barrier Reef, the world's largest living structure, may now be experiencing one of its most severe multi-year bleaching events ever recorded, if current trends continue. In Florida, reefs exposed to summer heat reached temperatures similar to a hot tub. Corals there began to die within days. Everyone thought the danger was pollution. Everyone thought the danger was overfishing. They weren't. The danger was heat, an invisible force that strips reefs of oxygen, alters water chemistry, and accelerates acidification. Some scenarios suggest that oceans may be warming faster than entire marine ecosystems can adapt, creating conditions no coral species in the last 30 million years has ever encountered. But heat is only one part of the collapse chain. Coral reefs now face a combination of forces rarely seen together in geological history. Rising temperatures weaken them. Acidification dissolves their skeletons. Pollution suffocates them. Overfishing disrupts the balance of predators and grazers. Disease spreads more rapidly in stressed ecosystems. Each factor alone is damaging. Together, they create a cascade. Here's the mechanism. Heat stresses the coral. Bleaching begins. Algae leave. Coral starves. Dead coral erodes. Fish lose habitat. Predators vanish. Reefs collapse. Coastlines lose protection. At first, the collapse seems ecological, but the consequences become economic. Coastal cities face more storm damage. Fishing communities lose income. Tourism declines. Insurance premiums rise. Food systems feel the strain. Coral reefs are the first domino. Here's why this matters for the modern world. The nations most dependent on reefs are often the ones least equipped to endure their collapse. Indonesia, the Philippines, the Maldives, Kenya, Belize, and dozens of Pacific Island states rely heavily on reef ecosystems for food security and economic stability. If reefs decline significantly, some analysts argue that migration patterns, employment structures, and national budgets could be reshaped if this historical pattern applies. And yet, the most unsettling part is not how reefs die. It's how fast they die. In previous extinction events, coral collapse took thousands of years. Today, vast sections of reef can perish in weeks. A single summer can undo centuries of growth. A single year can erase an ecosystem built over millennia. The danger isn't what we see on the surface. The danger is what we ignore in the water. Marine life that depends on coral shelter begins to disappear. Predatory fish lose breeding grounds. Sharks lose hunting corridors. The entire ocean food web, not just the reef, shifts. Some fish species decline. Others migrate. Some ecosystems fracture. Others reorganize. The ocean does not collapse all at once. It transforms. But what happens when the transformation accelerates faster than coastal societies can adapt? Some economists warn that coral decline could increase global food prices, reduce protein availability in developing regions, dose and reshape fishing industries. Others argue that coral loss could destabilize coastal economies, forcing governments to invest heavily in artificial barriers, aquaculture, or marine restoration. These costs accumulate quietly, invisibly, until they shape geopolitical decisions. Now we reach the central question of Section 1, the question that sets the stage for the next chapter. If coral reefs are the ocean's heartbeat, what happens when that heartbeat slows? What happens when the biological pulse that has guided marine life for millions of years falters within a single human lifetime? Because the oceans are not just warming, they are changing identity. And the reefs, those ancient engineers of life, may be entering the most fragile moment in their entire history. The answer lies in the collapse loop that begins after bleaching turns to death. Section 2 will reveal how the sequence unfolds and what the world looks like if the oceans lose their heartbeat entirely. To understand the full magnitude of what is unfolding in the oceans, we need to examine the collapse loop that begins the moment a coral dies. Because coral death is not an endpoint. It is a trigger, one that cascades through ecosystems, economies, and coastlines in ways that few people truly grasp. And here's what nobody tells you. When reefs collapse, they do not simply fade into quiet ruins. They set off a chain reaction that reaches far beyond the water. This is where the mechanism becomes unmistakable. When heat forces corals to bleach, some recover. But when the heat persists, the algae do not return. The coral starves. What was once a living organism becomes a skeleton of calcium carbonate. Fragile, empty, vulnerable. Currents begin to erode it. Storms break it. Waves grind it down. Within a few years, what was once a thriving ecosystem becomes rubble. Not habitat. Debris. And this is where the next crisis begins. The first system to feel the impact is the fishery system. Coral reefs support nearly 25% of all marine species. Millions of fish, invertebrates, and microorganisms that rely on the complex structure for food or shelter. When that structure disappears, fish populations collapse. Not gradually. Rapidly. Entire species may vanish from regions they've dominated for centuries. Some economists argue that this may trigger future food shocks, especially for nations that rely heavily on coastal fisheries. In Southeast Asia, East Africa, and the Caribbean, fish are not just a dietary preference. They are a primary source of protein. When reefs decline, local food systems become unstable, prices rise, and governments face mounting pressure to secure imports. This is where coral death becomes a national issue rather than an ecological concern. The second collapse strikes the coastal protection system. Coral reefs are natural breakwaters. They reduce wave energy by up to 97%, shielding coastlines from erosion, storm surge, and flooding. When reefs weaken, the waves grow stronger. Beaches retreat. Coastal towns face rising insurance costs. Critical infrastructure, roads, ports, power stations, becomes more vulnerable. And as sea levels continue to rise, the absence of reefs compounds the threat. Here's why this matters. Coastal protection is not a passive service. It is active defense. And losing that defense shifts the economic burden onto governments, taxpayers, and future generations. The third collapse targets the tourism system, one of the most vulnerable pillars of coastal economies. The Great Barrier Reef, the Maldives, Hawaii, the Red Sea, all depend on reef-driven tourism worth billions annually. When corals bleach, tourists cancel. Operators close. Coastal communities lose revenue they cannot replace. Not inconvenience, transformation. Once these three systems begin to fail, fisheries, coastal protection, and tourism, the pressure spreads into unrelated parts of society. Food prices rise, jobs disappear, coastal infrastructure weakens, government expenditures increase, public frustration grows. Analysts warn that some nations may face a form of economic stress where climate damage affects financial stability long before the disasters themselves become extreme. This is where the collapse loop becomes clear. Heat, bleaching, death, erosion, fishery decline, coastal vulnerability, economic fallout. But the collapse does not stop there. The ocean itself begins to reorganize. Fish migrate toward cooler waters, disrupting centuries-old fishing routes. Jellyfish populations surge in places where predators once controlled their numbers. Algae blooms explode, suffocating coastlines. Low-oxygen dead zones expand, pushing marine life into narrower corridors. Entire food webs shift poleward. In some scenarios, analysts suggest that ocean ecosystems may be realigning at a pace unseen in human history. If these modern signals continue, not extinction, reconfiguration, not disappearance, displacement. Here's what nobody tells you. Coral reefs are the training grounds of the ocean. Juvenile fish grow there before venturing into the open sea. Without reefs, fewer fish survive adolescence, reducing populations across vast regions. Even fisheries thousands of miles from coral reefs, such as tuna fisheries, feel the effects. But the mechanism driving this collapse is not a mystery. It is a sequence that scientists have studied for decades. Let me show you exactly how each stage fuels the next. Marine heat waves stress corals. Bleaching begins as algae are expelled. Starvation sets in when corals cannot feed. Mortality accelerates as heat persists. Erosion weakens reef structure. Fish decline as habitat disappears. Coastal damage increases without natural barriers. Economic stress grows across multiple sectors. Social strain intensifies as livelihoods shrink. Geopolitical consequences emerge as nations adapt unevenly. Yes, geopolitics. Because the collapse of coral reefs is not simply a science story. It is a migration story, a food security story, a sovereignty story. When reef fisheries collapse, coastal populations may move inland or across borders. When storm damage increases, governments may face rising debt and declining stability. When tourism industries fail, entire national budgets may fracture. Some analysts argue that reef collapse could become one of the defining economic forces of the 21st century for tropical nations, if today's patterns continue. But who loses first, and who adapts? Those who lose. Small island nations with limited land and high coastal exposure. Fishing communities that rely on reefs for food and income. Tourism economies centered on reef ecosystems. low-income regions unable to finance artificial barriers or restoration. Biodiversity hotspots that cannot migrate fast enough to survive. Those who adapt or gain advantage. Nations developing artificial reefs and marine restoration technologies. Countries with strong inland economies that can absorb coastal displacement. Regions investing early in aquaculture and sustainable fisheries. Tech-driven economies positioned to innovate in ocean restoration, mapping, and monitoring. Here's the trap: adaptation requires money, technology, and political will. Many nations with the most to lose have the least capacity to respond. And coral reefs, unlike forests or wetlands, cannot be regenerated quickly through human intervention. They grow slowly, they rebuild slowly, and once temperatures exceed certain thresholds, even restored reefs cannot survive without broader oceanic stability. Now we reach the future scenarios that define what happens next. Scenario 1. Partial reef recovery. If global temperatures stabilize, some reefs may adapt or rebuild. Restoration efforts, such as coral gardening, heat-resistant coral breeding, and artificial reef structures, could preserve fragments of ecosystems. Tourism may recover in specific regions. Fisheries may stabilize. But this scenario depends on rapid global coordination and climate mitigation. Scenario 2. Global reef collapse. If temperatures rise beyond 1.5°C, analysts warn that most tropical coral reefs may not survive. Fish populations decline further. Coastal nations face rising costs. Migration increases. Geopolitical tensions grow as food systems falter. This scenario reshapes economies for decades. Scenario 3. Long-term ocean reconfiguration. Reefs vanish, but new ecosystems emerge, dominated by algae, sponges, or heat-tolerant organisms. Human industries reorganize around new realities. Fishing shifts to different species. Coastal infrastructure adapts. This scenario mirrors past ocean shifts after mass extinction events, transitions that take centuries but begin within a generation. Here's why this matters now. Coral collapse is not theoretical. It is observable. It is measurable. It is happening in real time. The oceans are not waiting for future warming to change. They are changing now. And if coral reefs truly are the ocean's heartbeat, then what the world is witnessing is more than ecological loss. It is arrhythmia. It is irregular. It is dangerous. The ocean is trying to tell humanity something. The question is whether anyone is listening. Because if the oceans lose their heartbeat, the world that depends on them may soon follow.